Find all values for which f of x equals x plus 1 over x squared minus 49 are A, 0, B, undefined. So if you want f of x equals 0, then you have to set the numerator zero. So here we have x plus 1 equals 0. And so x equals negative 1. So this is the answer for A. B, undefined. So here when f of x is undefined, we have to set the denominator, 0. Then solve for x. So we have x squared minus 49 equals 0. So x plus 7 times x minus 7 equals 0 by factoring. So the answer will be x equals negative 7 and 7. Add 1 over x minus 5 plus 1 over 5 minus x. So notice that we have really similar denominators, but the signs are different. So first, we're going to take out negative 1. From 5 minus x, so we have 1 over x minus 5 plus 1 over negative x minus 5. So this is same as x minus 5 minus 1 over x minus 5. So that will give us 0 over x minus 5. So the answer is 0. Add 1 over 4x squared y to the 5th power plus 11 over 6x to the 6th times y. First, we have to find the lowest common denominator. So, the LCD of 4 and 6 will be 12. And since we have x squared and x to the 6th power, we take the higher one, which is x to the 6th. And we have y to the 5th and y, so we take the higher one, which is y to the 5th. So our LCD is 12 x to the 6th y 5th. Now we're going to rewrite each fraction with the denominator of the LCD, which is 12 x to the 6th y 5th. So we multiply 3x to the 4th power to get 12x to the 6th y to the 5th. So we multiply the same factor on top, so we get 3x to the 4th power. For the bottom one, to get from the left-hand side to the right-hand side, we multiply 2y to the 4th power. So we do the same thing on top, so we get 22y to the 4th power. Now we're going to add the numerators. So we have 3x to the 4th power plus 22y to the 4th power over 12x to the 6th y 5th. This is the answer. Simplify x plus 6 over x squared minus 36. So first, we're going to simplify each numerator and the denominator. So the numerator is already simplified, so you keep the x plus 6. And the denominator we can factor out as x plus 6 and x minus 6. So notice that we have the same factor, x plus 6, on top and the bottom, so we can cancel the factors. So we're left with 1 over x minus 6 as the answer. Simplify 5x squared plus 12x plus 4 over 2x squared plus 5x plus 3 divided by 3x squared plus 7x plus 2 over 2x squared plus 11x plus 2 times 3x squared plus 4x plus 1 over 5x squared plus 22x plus 8. First, we're going to factor out each trinomial. So first, let's look at 5x squared plus 12x plus 4. This could be factored as 5x plus 2 times x plus 2. And let's look at 2x squared plus 5x plus 3. This could be factored as 2x plus 3 times x plus 1. Now, the 3x squared plus 7x plus 2 equals 3x plus 1 times x plus 2. And the bottom one becomes 2x plus 3 times x plus 4. And the last fraction has 3x squared plus 4x plus 1, which is factored as 3x plus 1 times x plus 1. And the final one is 5x squared plus 22x plus 8, which is factored as 5x plus 4 plus x plus 2. 5x plus 2 and x plus 4. So let's go back to original fractions. So each fraction is written as, the first one is 5x plus 2 times x plus 2 over 2x plus 3 times x plus 1. Now, since we have a division sign between fractions, we're going to change the multiplication and flip the second fraction. So we have 2x plus 3 times x plus 4 on the numerator. And on the bottom we have 3x plus 1 times x plus 2. Now, finally, we multiply the third fraction, which we have 3x plus 1 times x plus 1 over 5x plus 2 times x plus 4. Since all the trinomials are factored, we can go ahead and cancel. So notice that we have 5x plus 2 on top and bottom, and x plus 2 and x plus 1 are canceled, and 3x plus 1 is also canceled, and 2x plus 3 is also canceled, and finally x plus 4 is also canceled. So basically we are left with 1 for each numerators and 1 for the bottom. So we have 1 over 1, which is 1 as the answer. Simplify. X squared minus 9 over x cubed minus 27 divided by r squared plus 6r plus 9 divided by r squared plus 3r plus 9. First, we have to factor each trinomial and binomial. So r squared minus 9 is factored as r plus 3 times r minus 3. R cubed minus 27 is written as r cubed minus 3 cubed, which by cubic formula we have r minus 3 times r squared plus 3r plus 9. So let me rewrite each fraction. So we have r plus 3 times r minus 3 over r So we have r minus 3 times r squared plus 3r plus 9. And then we're going to flip the numerator and denominator of the second fraction since we have a division. So we have r squared plus 3r plus 9 on top. And we can actually factor out an r squared plus 6r plus 9. So we go ahead and do that before we put in the fraction. So we can factor that as r plus 3 times r plus 3. So that will go on the bottom. R squared plus 3r plus 9 is a prime, so we cannot factor this. So now we're ready to cancel. So notice that we have r plus 3 on top and bottom, and r squared plus 3r plus 9 also are on top and bottom, so we can cancel that term. And r minus 3 as well. So we're left with r plus 3 on the bottom and 1 on top. So the answer is 1 over r plus 3. Add x over x squared minus 10x plus 24 put us 3 over 6 minus x plus 1. First, factor out the denominators. Then find the LCD. So first we have x squared minus 10x plus 24, which is factored as x minus 4 times x minus 6. And the second one, 6 minus x, could be factored as negative x minus 6, where I factored out -1. So the LCD here will be x minus 4 and x minus 6. So x minus 4 times x minus 6 will be the LCD. So we're going to rewrite each fraction in terms of LCD. So x over x minus 4 times x minus 6, which is the first fraction, and 3 over minus x minus 6, this is the second fraction, and then 1. So since the first fraction already has the LCD, the first fraction does not change the shape. The second fraction is missing x minus 4, so we're going to multiply top and bottom by the x minus 4. The last fraction, which is 1, is think that as 1 over 1. So since we want the x minus 6 times x minus 4, we're multiplying the same factors on top as well. Now we're ready to add. So we have x minus 3 times x minus 4 plus x minus 6 times x minus 4 over x minus 6 times x minus 4. So let's clean the numerator. X minus 3x plus 12 plus, by foiling, we get x squared minus 10x plus 24. So we have x squared, and by combining like terms, we have negative 12x and plus 36. And we can still factor this trinomial as x minus 6 squared. So we have x minus 6 squared, or x minus 6 times x minus 6 on top, and on the bottom, the LCD, x minus 6 times x minus 4. So since we can cancel the x minus 6, the answer will be x minus 6 over x minus 4. Add a minus 2 over a squared minus 4 plus a over 2, a minus 2, 1 over a minus 2 plus a over a plus 2. First, we're going to factor each denominator. So we have a plus 2 times a minus 2 for the first denominator. And the second denominator, a minus 2, is already factored, so we're done. And third denominator is also factored out, so we're already done. So the LCD will be a plus 2 times a minus 2. So I'm going to write each fraction with the denominator of the LCD. So the first fraction already has the LCD, so we write the same fraction. The second fraction is missing a plus 2, so we multiply top and bottom by a plus 2. So we have a plus 2 over a plus 2 times a minus 2. And the last fraction is missing a minus 2, so we multiply a minus 2 by top and bottom. So we have a plus 2 times a minus 2, and as the numerator we have a squared minus 2a. Now we're ready to add. So when we add, we get a minus 2 plus a plus 2 plus a squared minus 2a over the LCD. Now we can simplify the numerator by combining like terms. So a squared and a terms are gone, and 2 also canceled out, so we just have a square on top, and on the bottom we have a plus 2 and a minus 2. So this is the answer. Simplify 2 over x plus 2 over y over x over y minus y over x. First, let's find the LCD of x, y, and y on x. LCD of all 4 fractions. So the LCD here is xy. So what we're going to do is we're going to multiply each small fraction by the LCD xy. So first, 2 over x times x over y is 2y, since x cancels out. In the second one, 2 over y times x over y, since y's cancel out, we have left with 2x. On the bottom, we have x over y times xy. So the y's cancel, so we have x squared minus x is gone, so we have y squared on the bottom. Now notice that we can factor out 2 on the numerator, so we have 2 times y plus x, and on the bottom we can factor that as x plus y times x minus y. Notice that we can cancel the y plus x on top and x plus y on the bottom, since these 2 terms are identical. So we are left with 2 over x minus y as the answer. Three x over 2 minus x minus 1 over 4 equals 1. First, find the LCD of 2 and 4, which is 4. So we're going to multiply every term in the equation by 4. So by multiplying 4 to each term, we have 6x minus x minus 1 equals 4. By distributing negative 1, we have 6x minus x plus 1 equals 4. So we have 5x plus 1 equals 4. That will give us 5x equals 3. So the x equals 3/5. Solve. 2 over x squared minus 1 minus 1 over 2 equals 1 over x minus 1. Find the LCD of x squared minus 1, 2, and x minus 1 is the first step. So x squared minus 1 is given as x plus 1 times x minus 1. So the LCD here will be 2 times x plus 1 times x minus 1. Now we're going to rewrite each. Now we're going to multiply each fraction by the LCD. So we have 2 times x plus 1 times x minus 1 times 2 over x squared minus 1 minus 2 times x plus 1 times x minus 1 times 1 halves equals 2 times x plus 1 times x minus 1 times 1 over x minus 1. So these two cancel, so we're left with 2 times 2, which is 4, minus, we can cancel out the 2's, so we have x plus 1 times x minus 1. That equals 2 times x plus 1. So 4 minus x plus 1 times x minus 1 is x squared minus 1, so equals 2x plus 2. So 4 minus x squared plus 1, and we're going to move 2x into on the other side, so we have minus 2x minus 2 equals 0. So we have negative x squared minus 2x plus 3 equals 0. By multiplying both sides by negative 1, we have x squared plus 2x minus 3 equals 0. Now let's factor out. So we have x plus 3 times x minus 1 equals 0. So the x equals negative 3 or 1. Now we have to check your answer, since denominators contain variables. If x is negative 3, the denominator does not become 0. However, if x equals 1, this value will make the denominator 0. So x cannot be 0, x cannot be 1. This is called extraneous answer. So the answer is only x equals negative 3. Jeff can mow a grass in 5 hours. Mark can do the same job in 10 hours. How long will it take to do the job if the two of them work together? First, let's look at the rate of job for each person. Since Jeff can mow grass in 5 hours, in 1 hour he can finish 1/5 of one job. And Mark can do the same job in 10 hours, so he can do 1/10 of job in 1 hour. Since they work together, we add these two rates. And since we don't know the time they finish the work, so T will be the time that both take to complete the work. So if they work together, they can finish in T hours, so they finish 1 out of T job in 1 hour. So that your equation is 1/5 plus 1/10 equals 1/t. Now let's solve this equation. The LCD here will be 10t. So we multiply 10t to each term to eliminate the fraction. So we have 2t plus t equals 10. That will give us 3t equals 10. So t equals 10 hours. Or you can write this as 3 1/3 hours. At dairy plant, a milk tank can be filled in 6 hours using the inlet valve. Using the outlet valve, the tank can be emptied in 8 hours. If both valves are open, and milk is being pumped into the tank, how long will it take them to fill the tank? So let's look at the tank here. Milk is coming in from inlet valve, and milk is going out with outlet valve. Since milk tank can be filled in 6 hours, inlet valve can do its job 1 out of 6 job per hour. So it means 1 out of 6 tank can be filled in 1 hour. Since the tank can be emptied in 8 hours with using the outlet valve, 1 out of 8 of a tank to be emptied in 1 hour. So in 1 hour, we have 1/6 coming in, however 1/8 coming out. So we have the difference, which is 1/6 minus 1/8 is how much we have in 1 hour. So since we do not know how long it takes the tank to be filled, we let t be the time. So that will be 1/t on the right hand side. So the LCD here is 24t. So the multiplying 24t on both sides, we have 4t minus 3t equals 24. So the t equals 24 hours. So in 24 hours, the tank can be filled completely. A train and car leave from Pasadena. California Railroad Station at the same time, and headed for the State Fair in Sacramento. The car can drive 60 miles per hour, and the train averages 80 miles per hour. If the train arrives at the fair 2 hours ahead of the car, find the distance from the railroad station to the State Fair. So since this is the motion problem, I'm going to graph a chart. Where the top row is for distance equals rate times time, and second row is for the car, and third row is for the train. Since car average is 60 miles per hour, we know the rate for the car, so 60 goes in the box, and train's average is 80 miles per hour, so we put that in the box as well. Now, since we don't know the time for train or car, we let t be the time for car. So we let the time that car took t. So when you read the sentence, if the train arrives at the fair 2 hours ahead of the car, that translates that the train took 2 hours less than the amount the car took. So train took t minus 2 hours. Now, distance-wise, we can find by multiplying rate by time. So the distance for car will be 60t, and distance for train will be 80 times t minus 2. Now notice that the train and car took exactly the same distance, so their distance should be equal. So 60t equals 80 times t minus 2. This will be our equation. Now let's solve for t. We have 80t minus 160. So by subtracting 80t from both sides, we have negative 20t equals negative 160. So t equals 8. So car took 8 hours. And then train took 2 hours less than that, so 8 minus 2, which is 6 hours for train. Now, since we have to find the distance from the railroad station to the state fair, we have to substitute t, which is 8 hours, into the 60t. So this will give us 60 times 8, which is 480 miles. This is our answer. The sum of the reciprocals of two consecutive integers is 15 over 56. Find the two integers. So we let x be the first integer. Then the x plus 1 will be the consecutive second integer. The sum of reciprocals of these two integers will be 1 over x plus 1 over x plus 1. And that is equal to 15 over 56. Let's solve the equation. Notice that the LCD equals 56x times x plus 1. So we multiply both sides by 56x times x plus 1. So we have 56x plus 1 for the first term since x canceled, plus 56 times x plus 1 for the second term, and at last we have 15 times x plus 1. Okay, so we have 56x plus 56 plus 56x And so we have just (56x) for the second term. So equals 15x times x plus 1. So by adding like terms, we have 112x plus 56 equals 15x squared plus 15x. By subtracting from both sides, we get 15x squared minus 97x minus 56 equals 0. Now we can factor trinomial and we get the answer. So we have 15x plus 8 times x minus 7 equals 0. So the x is either negative 8 over 15 or x equals 7. But the problem says that the x is the first integer, so x has to be 7. So we have 7 for the first integer, and second integer will be 8. Simplify. 24 square root of x times square root of 4x squared y cubed. First, we can multiply the inside the square roots, so we have 4x cubed y cubed. Now notice that the 4 is 2 squared, and x cubed is written as x squared times x, and y cubed is written as y squared times y. Once we have exponents of 2, we can take out the factors. So we have 24 times 2 times x times y without the exponents. So the inside we still have x and y left. So the answer will be 48xy outside times square root of xy inside. Simplify. 25 over 16 to the 1/2. So 25 over 16 to the negative 1/2. Without using negative exponents, we can write this as 16 over 25 to the 1/2 by flipping the numerator and denominator. So 16 over 25 to the 1/2 is written as the square root of 16 over 25. So the square root of 16 over square root of 25 is 4 over 5. Simplify. 8 to the negative 2/3. 8 to the negative 2/3 is written as first 1 over 8 to the 2/3 without using the negative exponent. Now, 8 to the 2/3 is 1 over the cube root of 8 squared. The cube root of 8 will be 2, so 2 squared will be 1 over 4. Simplify. Square root of 81 over 169. First, we can break the fraction into two pieces. So we have the square root of 81 over the square root of 169. So we have 9 over square root of 169, which is 13 as the answer. Simplify. Square root of 4xy squared times square root of 5yz over the square root of 20xyz. First, we're going to multiply the numerators. So we have 20xy to the third power times z over 20xyz on the bottom. Since we have square roots on both top and the bottom, we can combine them in one radical. So we have the square root of 20xy cubed z over 20xyz, so that we can cancel the numerators and the denominators. So 20x and z are canceled, so we're left with y squared. Since y1's cancel, so y squared is left inside of the radicals. Well, the y squared has a 2 as an exponent, so we can bring that out, so the answer is just y. Simplify. 54, 8 to the negative 3/4 times the b5 over 2 times 8 to the negative 2 times b squared to the 2/3. So first, we're going to simplify the inside. So 54 divided by 2 will give us 27 on top. And 8 to the negative 3/4 minus negative 2 will give us 8 to the negative 3/4 plus 2. So we have 8 to the negative 3/4 plus 8 over 4, which is 8 to the 5/4. Since this is positive exponent, we're going to put the 8 to the 5/4 on top. And finally, b to the 5th minus 2 is b cubed, so it is also on top of fraction bar. So since we have only one on the denominator, we just have to write this as 27 8 to the 5 over 4 times b cubed to 2/3. Now we're going to distribute 2/3 to each term, each factor. So we have 27 to the 2/3 times 8 to the 5/4 times 2/3 times b cubed times 2/3. 27 to 2/3 means cube root of 27 squared. And here we can cancel 2 and 4, so we have a to the 5 over 6. And 3's canceled, so we have b squared. So 27 cube root of 27 is 3, so 3 squared is 9. So the answer is 9a to the 5 6b squared. Simplify. Fourth root of xy to a 20th power. Fourth root of xy to a 20th power is written as xy to a 20 over 4th power, so which is xy to the 5th power. So the answer is x to the 5th times y to the 5th. Simplify. Square root of 2 plus square root of 3 over square root of 2 minus square root of 3. First, we're going to multiply top and the bottom by the conjugate of the denominator, which is square root of 2 plus square root of 3. So when we multiply, notice that these two are multiplied by the difference of squares. So we have square root of 2 squared minus square root of 3 squared. And on top, we have square root of 2 plus square root of 3 squared. So the bottom becomes 2 minus 3, and numerator we have 2 plus 2 square root of 2 times 3 plus 3. So we have 5 plus 2 square root of 6 over negative 1. So the answer is negative 5 minus 2 square root of 6. Simplify. 2 over 6 plus square root of x. Here we have to multiply top and bottom by the conjugate of the denominator, which is 6 minus square root of x. So we multiply the 2 to 6 and negative square root of x. We have 12 minus 2 square root of x over 6 squared minus square root of x squared, which is 12 minus 2 square root of x over 36 minus x. Simplify. 4x over cube root of 5y squared. Here, to get rid of the cube root of 5y squared, we're going to multiply the cube root of 5y squared on top and bottom twice, so that we can have 3 5y cube root of 5y squared, so we can get rid of the cube root. So we have 5y squared on the bottom since we have a 3 cube root. On top we have 4x times the cube root of 25y to the 4th power. Now cube root of 25y to the 4th power can be cancelled, can be simplified. Y to the 4th is written as y cubed times y, so we can get the y out, so the y times cube root of 25y. So we have 4xy times cube root of 25y over 5y squared. One y's can be cancelled, so the answer is 4x times cube root of 25y over 5y. Simplify. 5 square root of 3 over square root of 5. Since we have a square root of 5 on the bottom, we multiply the exactly same thing on top and bottom to get rid of the square root. So square root of 5 times square root of 5 is a 5. And on top we have 5 square root of 3 times 5, which is 15. So since 5's can be cancelled, we are left with the square root of 15. Solve. Square root of 2x plus 1 plus 7 equals x. First, we're going to isolate the radical term by itself. So we subtract 7 from both sides. So we have x minus 7. Then we're going to square both sides to get rid of the radical. So we have 2x plus 1 equals x squared minus 14x plus 49. By subtracting 2x and 1 from both sides, we have 0 equals x squared minus 16x plus 48. Then we can factor out the right-hand side. So we have x minus 4 times x minus 12 equals 0. So x equals 4 or 12. Now let's check out our answers. If x equals 4, then we have 2 times 4 plus 1 plus 7, which is the square root of 9 plus 7, which is 3 plus 7 is 10, which is not 4. So 4 does not work. If x equals 12, then 2 times 12 plus 1 plus 7 equals the square root of 25 plus 7, which is 5 plus 7, which is 12. So 12 works. So the answer is only the 12. Simplify. A. I to the 1,225. B. I to the negative 6. C. 5 minus 2i over 3 plus 2i. So let's look at the A. I to the 1225. I to the 1225 could be written as I to the 1224 times I squared. Actually, just I. So I to the 1224 is written as I squared to the 612 times I. Now we know that I squared is negative 1, so negative 1 to the 612 times I, which is 1 times I, so the answer is I. I to the negative 6 is written as 1 over I to the 6, which is also written as I squared cubed. Again, we know that I squared is negative 1, so negative 1 cubed is negative 1, so the answer is negative 1. C. 5 minus 2i over 3 plus 2i. Here we're going to multiply 3 minus 2i on top and bottom, which is the conjugate of the denominator, to eliminate I. So on top, by foiling, we have 15 minus 10i minus 6i plus 4i squared. On the bottom, we have 3 squared minus 2i squared. So the answer is 15 minus 16i minus 4, since I squared is negative 1, over 9 minus 4i squared. So 15 minus 4 is 11, so 11 minus 16i over 9 plus 4, since I squared is negative 1. So the final answer is 11 minus 16i over 13. Multiply 3 plus the square root of negative 4 times 1 plus the square root of negative 1. Since we have negative number inside the square root, first we have to change the terms with using I. So 3 plus square root of negative 4 times 1 plus square root of negative 1 becomes 3 plus negative 1, square root of negative 1 times square root of negative 4 times 1 plus square root of negative 1 times square root of 1, which is 3 plus 2i times 1 plus 1i. By foiling, we have 3 plus 3i plus 2i plus 2i squared. By combining like terms, we have 3 plus 5i minus 2, which will give us 1 plus 5i as the answer. Solve for Q. 1 over P plus 1 over Q equals 1 over F. First, we're going to find the LCD of P, Q, and F, which is P times Q times F. Then we're going to multiply each fraction by P, Q, F to eliminate the fractions. So we have QF plus PF equals PQ. Since we are solving for Q, I'm going to subtract QF from both sides. So we have PF equals PQ minus QF, so that we can factor out the Q to get P minus F times Q on the right-hand side and PF on the left. Finally, to isolate Q, we divide both sides by P minus F. We have the answer, Q equals PF over P minus F.